As promised, here's 3 different ways we can apply Faraday's law along with mass, current, and time to figure out things about electroplating or changes in mass related to electrolysis. The first one's probably the most different or maybe difficult of them. What is the charge of a lead ion if 29 grams of lead can be plated by a 10 amp current applied for 1.5 hours? So the first thing, the connection that's really important is the connection between amps, which is coulombs per second, and the time. So if we look at this, 1.5 hours is 60 minutes and 60 seconds. So I multiply across, and then I know in this case, I have a really high current, 10 coulombs every 1 second. The number of coulombs connects to moles of electron based upon the charge on each electron. So I set all of that up and I am able to figure out when this runs at this current, I get 0.56 moles of electrons. Then I need to think about, well, how many moles or how much lead is that? Well, 29 grams is 0.14 moles of lead. This is a tricky one to do all in one long dimensional analysis because of the unknown kind of comes in the middle. But now I know how many moles of electrons there are, and I know how many moles of lead. So the moles of electron, the moles of lead tells me that this is the reaction for the lead plus 4 ion, 4 electrons for every mole of lead. In a problem like this, hopefully it would connect. If it was aluminum, it would be 3 electrons, or maybe calcium would be 2, and we would see that connection that makes sense. Because one of the ions of lead that can form is lead plus 4, this does make sense. The second one, what mass of silver? Very similar to the first, if we have a certain current and 72 minutes. So we change from minutes to seconds because amps is coulombs per second. Coulombs, there's this many coulombs in a mole by Faraday's constant. We would need to know or remember or look up on our cell potentials that, remember, silver always has 1 mole of electrons, or it forms a +1 ion. We use the molar mass of silver to get here. We get a whole bunch of silver. So that'd be awesome. If we had this 1 molar solution of silver and we were able to put this much current through it for just over an hour, we would get a lot of grams of silver. The last one, how much time would it take to plate 1 gram of aluminum if we have a current of 1.5 or 4.5 amps? Well, we're kind of working it backwards here. We've got 1 gram. We can figure out how many moles that is. It's less than a mole. Each mole of aluminum needs 3 moles of electrons. 1 mole of electron has 96.45 in terms of coulombs. And then we got our coulombs per second. Because it just generically asked how much time, we didn't have these minutes or second conversions to worry about. But we have 2,380 seconds. Divide that by 60 would get our minutes. Divide that by 60 would get our hours, depending what we're asked. A lot of times these are free response, but we also need to be able to do kind of fast and loose enough estimations that we can do this on a multiple choice. This is around 100,000. We would be dealing with probably currents or molar masses that are also really easy to be using, or maybe not even going all the way to molar masses and stopping at moles. The key is the moles of electron per moles of, in most cases, metal, getting that right to make that connection.